Welcome to this fourth lecture on machine learning. In our third lecture, we studied the problem of classification. Classification, as you saw, we are given a data set, and then what we have to do, we have to classify the data set into two or more categories. The example that we studied there, that was this example of binary classification, in which data could be and is separated into two classes: height and weight were the inputs. We had height along this and weight along this. These were inputs, and from these inputs, see, we were able to these inputs gave us these points, like this, point like this, point like this, and point like this, for example, and then point like this. Two types of points. The first type is this obese type. This type is obese. These are obese persons, and these are non-obese persons. We were able to separate the two types of data points into two groups by a line. I told you that in fact, the fact is that weight and height people who are to be classified as obese and non-obese, they cannot be divided into two categories by a straight line. You cannot find a straight line that can have obese on one side and non-obese on the other side, because you have this relation between height and weight. See, relation between these two. BMI is equal to that is equal to weight by height square. By cross multiplication, weight is equal to BMI into height square. The relation between these two is a non-linear relation. You can see there is square on height, so it's non-linear relation. That means you cannot have this straight line. It will be a curve. This curve is actually called parabola, but we need not discuss that here. But one thing is there, that the height and weight data can be separated into two classes, but non-linearly. Non-linear means by a curve, not by a straight line. There are not many true cases of binary classification that can be separated by a straight line. But this case, this separation by linearly separable case, this becomes very, very important for machine learning. And if someone wants to really learn as quickly as possible what actually machine learning is about, how do machines learn, this is the best topic to start with. Classification. Although the routine trend in this teaching of machine learning is that we don't take classification as the first model. We take another this model that is called regression model. We take that as the first. But I am taking in a way, I am taking a different route. I have simply chosen this classification as my first topic because this will make you understand how machines learn in a very easy way. That is the reason. So to sum up, data can be classified into two or more categories, and that in case of two categories, the classification is called binary classification. And this binary classification can be done either by a straight line or by a curve. If it is done by straight line, it is called linearly separable classification. If not done by line, if done by a curve, then it is called non-linear classification. Now we are talking about linear classification. Now, There are other this weight and height. These are not the only types of these inputs. Only this is not the only case in which classification is involved. There are many other cases. For example, classification is involved when you have to classify whether a given email will be spam or non-spam. Spam or non-spam. Now, if it is spam, you may say, you may code that by saying that output is +1. Just as output was coded by +1 if the output is obese, or if it is non-spam, you will say -1. So again here you have two groups, spam emails and non-spam emails. What are the inputs? On the basis of which inputs do we classify a given email as spam or non-spam? Actually, the inputs are more than two. They are more than two. What are those? Those are the words. Spam emails use some words more frequently as compared to non-spam emails, and we keep track of those words. If those words cross a certain frequency, if they cross a certain frequency, we classify it as spam or otherwise non-spam. Anyhow, this means that email can also fall within the realm of classification. Similarly, for example, for your satisfaction, another example that I can quote is, suppose there is a patient. There's a person, not necessarily patient. There's a person, and every person has a certain level of cholesterol level, and certain BP. Now, high BP, people with high BP are at the risk of several diseases. One of those is, say, heart disease. A person with high BP has a higher risk of heart disease. A person with low BP has a lower risk of the heart disease. Similarly, cholesterol. If cholesterol level is high, then this risk of heart disease is high. If cholesterol level is low, then risk of the heart disease is low. So this is the situation. Now, this situation is now we see now. Suppose we have a graph like this, and along this axis we have BP. We take BP of different persons, and along this axis we take cholesterol, which this is cholesterol. Okay, cholesterol and BP. These are our inputs. Based on these inputs, based on the information provided by BP and cholesterol, we can either classify a particular person at being high risk, or we can classify him at being low risk. It depends upon these inputs. Now, these inputs can be, say, for example, a person with high BP, he will be classified as at high risk person for heart disease, and a person with low BP will be classified as a person with low risk, provided for the cholesterol level is same. So we have two persons who have same cholesterol level. Then a person with high BP will have higher risk of heart disease, and a person with low BP will have lower risk of heart disease. Thus, these two serve as our inputs. And what is the output? High risk and low risk. High risk, we classify that as, high risk is classified as +1. High risk patients, they are labeled as +1. Low risk, that those patients can be labeled as -1. I hope this is clear to you now. And as we proceed ahead, we will find more examples of this classification. Classification examples are very interesting examples, but we need to cover some ground in order to enjoy that. And here is what we are going to do now after this. See, let us now introduce you to something that was actually responsible for this beginning of artificial intelligence revolution. In 1944, some dates around this, yes, of course, if I remember it correctly, it is around 1940s. The exact date I am not sure about that, but somewhere in this during this time, There were two persons. A psychologist, his name was it is written as M, small c, and then capital C, Macula. I'm sorry if I'm wrong in spelling. If I'm wrong, I'm sorry for that. Uh, I don't mean any this harm or any this. I don't mean hurting anyone. So Macula and Pitts, these two great persons, history will remember them as the originators. These are the persons who sowed the seeds of artificial intelligence or machine learning. He was a psychologist, and this person was none. He even this person did not have a degree. He was not. He had no schooling at all, like Michael Faraday. He had no schooling. He was so poor, and he did not have a home throughout his life. He did not have a home. So such was the petty condition under which he spent his life. But even this person, in those harsh, in those extremely unfavorable conditions, even under those extremely unfavorable conditions, he contributed to the world something that you see what that thing is now, that what that thing has become now. We don't have time, otherwise it would have been better to read the story of their these two collaboration. How did they meet and what they did? Then he was strong in mathematics, physics, mathematics, logic. He was strong in psychology and some physiology. Now, he knew those were the days, that was the time when it had been discovered that human brain consists of neurons. Inside human brain, there are special types of cells called neurons. Neurons. These are special cells inside human brain. There are other types of cells, but we are concerned with neurons because we know, and it has now been proved that it is the neurons which mostly process this information. There are other cells which support these neurons. There is a cell type called glial cells, about which something strange has been recently discovered. I don't have time for that. Let us proceed ahead. Suppose I have a neuron. This this is a neuron. Okay, this is cell body. Of course, this is not the shape of actual neuron, but I am not concerned here with the shape because simply because physiology or this neurology is not my topic here. Although this does pertain to neurology more than to any other subject. This particular topic. Okay, with the neuron now here, you now have neuron here. So what is this neuron about? Macula had a realization that neurons can add, subtract, divide, multiply numbers. How did he know they can? Because, if I ask you a question, what is 9 into 2? You will readily answer me 18. But how did you use calculator for calculating this? No, you did not use calculator. Then what did you do? You used your brain. But in your brain, what is it that actually performs this computation? Macula said that it must be the neuron. Neurons in the brain. Suppose this is a particular neuron. One neuron is connected to several other neurons. The number with which one neuron is connected can be as much as 1,000 or more than that. In fact, when a person is born, he has every one of his neuron is connected to a huge number of other neurons. Then what happens? Something strange happens, that pruning occurs of these connections, and then only a limited number of connections are left. Other connections are simply deleted, and this is done. This has been now seen that this is done by glial cells. Okay, without going into that detail, this is a neuron. Now, this neuron receives inputs from several other neurons. Let's take just two neurons because that is the simplest thing that we can do. Simplest thing, we cannot take 1000 these inputs at one time. That will be formidable for us. So these are two neurons, these are, sorry, two signals. What is this signal? When I say this is signal, what is coming to the neuron? It is electric current that's coming towards the neuron. But don't worry, this electric current has such a low magnitude that is not going to harm anyone. The voltage associated with this electromagnetic current is so small. It is if you can understand, if you are acquainted with a little bit of physics or electrical engineering, then you can better see. In even chemistry, people know it, that this is minus 90 millivolt. The inside of a neurofiber is at a voltage of 90 minus 90 millivolt with respect to the outside. Now, millivolt, that means 1,000th of a volt. Even your dry cell, the torch cell, or this remote cell, that has a voltage of 1.5 volt. And that has now something having a voltage which is 1,000th of this. You can yourself see how small this voltage is. But these small things, God has actually, God does not ignore small things. In fact, most of the most beautiful things of this universe, they arise from small things that you can discover in physics, especially when you see these galaxies and stars being held together by a small thing, very, very weak force of the world, the weakest, in fact, that is called gravitational force. Anyhow, now, what does this neuron receive? It receives an electric signal from where? Where from does that electrical signal come? That comes from another neuron. Then, so that neuron is here. I am not showing that. Okay. Now, this electrical signal which comes from that neuron to this neuron, it is carried by a neurofiber of that neuron. Okay, let me show it. This neuron, and this is some sort of a wire coming out of this wire. Some sort of a wire. It is of course not copper wire, but it carries this it's called neurofiber axon, to be precise. Now, this nerve fiber also carries, it can conduct current. Now, this nerve fiber is not directly connected to this nerve fiber of this. These are not directly connected. Rather, there is a small gap between the two. Very small, but it is there. This gap is called synapse. Synapse. Okay. The neurofiber which carries this signal from this neuron is called axon. We don't need that much of knowledge right here. And this is called dendrite. No need to remember them. No need to remember right at this stage. Just look at the broader contours of this problem. This synapse is there, and how can current go from this to this? If there is high voltage, it could go in the form of sparks, but the voltage is so small, you can see it. You don't expect this to happen here. Then what is actually happening? What is happening? It has been discovered by research, through research, that when signal reaches this end of the fiber, it releases some chemical substances into this gap. This is the gap. It releases chemical substances into the gap. These chemical substances are called neurotransmitters. And these neurotransmitters then travel towards this end. They are released here and go to this end. When they go to this end, they trigger something, they do something with it there at this end, that a current then flows again from this. One wonders why God chose this. Why didn't He directly connect this neurofiber of this neuron directly to the neurofiber of this neuron? Why didn't He do that? And there is of course some wisdom, great wisdom in it. Great wisdom in it. What is it? If we have a purely pure electrical connection, say this is one neuron fiber, this one, and let's join them. If there is a pure electrical connection, then current will flow straight away through this fiber into this undiminished. Current does not diminish as it passes. It is the voltage of the current, that is pressure of the current, which diminishes. Anyhow, current will flow through this wire as it goes. It flows. Okay. As current flows directly, whatever current was coming here, suppose the current coming here is 10 milliampere, microampere. Microampere is a small, very, very small. In fact, let me tell you, the 1 millionth of an ampere. Now, suppose 10 microampere current is coming from this. 10 microampere current is coming from this. And what happens is that 10 will go there. 10 microampere current will go there. But in case of this synaptic junction, in case of, because chemistry is involved here, the role played by chemistry is here remarkable, remarkable. And when these neurotransmitters are secreted into this space, the current that will be triggered here depends on many things, and it's not must that the current will be 10 microampere here as well. It will depend, for example, on the amount of neurotransmitters secreted by this, amount of neurotransmitters that leave this and go to this. If the amount is very small, only very small current will flow here. If the amount is large current will flow here. Okay. Now, it not only depends upon the concentration, the amount of the neurotransmitter secreted, it also depends upon the nature of the neurotransmitter. Our brain does not use just one type of neurotransmitter. There is not one type of neurotransmitter. There are many types of neurotransmitter, and different neurotransmitters have different this effect on these fibers. So, what is the fun of using this? Fun of using this is that we can control the coming current, and as per our requirement, we can let only, say, if it is 10 microampere current coming from this, we can let only 5 microampere current go ahead, or we may allow 0.1 microampere current. This means we can modulate the current, we can change the current here. That's just the great advantage offered by this. It's not that we can. When I say we can, I don't mean humans can. Humans can as such. We do not have much control on this. Of course, we have had using some drugs like dopamine and other things, things like that. We can exert an influence of this, but the nervous system itself regulates the amount of neurotransmitters released, the type of neurotransmitter, and thereby the nervous system itself regulates the amount of current going to this. That is okay now. Yeah, some idea of why there is this junction, why there is this gap. Okay, now let us go to another aspect now. Another aspect is, suppose you have the neuron. Okay, you have neuron, and when an input comes to neuron, suppose input is x1, the neuron gives it some weight that is called w1, weight w1. I will tell you what this weight w1 is. Same is the case here, x2, and neuron gives it the weight w2, x2. What is this weight now? That's my next this topic. What is the weight? This weight, what I'm talking about? Yes, let me tell you. You have, suppose it is a part of Srinagar city, some part of Srinagar city, and there are houses, or rather a colony is being built somewhere here, a colony, of course, and prices, these houses constructed are on sale. The price of a house, let us denote that by P, price of house, depends upon is denoted by F. F is the function. It means price depends upon. At the moment you look at this, you should translate this into depends upon. Price of a house depends upon. It is plinth area, of course, and many factors, not one, many factors. For example, price could depend upon this plinth area. It could depend upon the number of bathrooms in this house. It could depend upon the number of these, say for example, the furniture. It could depend upon the material used by the person. It could depend upon number of stories of this, and so on, so many things. But I will simply use an example in which the price depends upon just two variables, say plinth area and number of number of washrooms. So suppose I can write, then I can write plinth a this price is equal to, I cannot write this thing. What I am going to write, price is equal to area plus number of washrooms, washroom number, w, washroom number, or n. It would be better to write n because I'm going to use this w for some other purpose. So I write n, area and area and number of washrooms. Okay, but you cannot write it like this. There are reasons why you cannot write it like this. For example, if your area, suppose the area is 1000 square feet, 1000 square feet, plus number of bathrooms is say uh, four bathrooms, 1000 square feet plus four bathrooms. Now you cannot add these two things because one is 1000 square feet, the other is a pure number. You cannot add. You can add a number to a number. You cannot add a non-number to number. This is not a number, pure number. It has a unit, square feet. It's called scalar quantity. Now this you cannot add. Yes, of course, it had been, if it had also been area, then you could add. So writing this thing is wrong. And there is one more reason why it is wrong. That is the reason that I am going to discuss. That is the reason. Even if it had been correct, even if there would have no problem, there would not have been any problem of units, even then it is incorrect. Why? Well, because if you suppose you double this area, plinth area, suppose you take two houses, one house is here and another house is a small house here in the same locality, but a small house with half of the plinth area, half of the plinth area as compared to this. Call it first house, second house. Now this is area that is double of this. If you double area, if area is doubled, it's not necessary. If area is doubled, it's not necessary that price will double. Price may be, for example, if you double the area, price may be less than double. Price may increase but less than double. It can increase. It may increase more than double. That is the problem. Then there is a problem. Why should it increase more than double? Why should it increase less than double? Because it actually price does not depend upon only this a plinth area. For example, we are assuming that all other factors here are same. Even if all other factors here are same, for example, number of washrooms are same, everything else is same, but only areas differ. Still, it is not necessary that price would be here double. For example, the owner of this house might be, say, for example, a little bit tough guy, and that tough guy may demand more than the double of the amount that you are being asked for this house. So it is not necessary that if you double area, this will double. Now, if you write something as this, P equal A, then mathematically, if you double area, this will double. See how? Put area equal to 1000 square feet. 1000 square feet. So price will be 1000 square feet. Now double this area. That means take 2000 square feet. 2000 square feet. Put 2000 here. Price will double. This means if area doubles, price doubles. You can see. Area doubles, price doubles. As I told you, that is not necessary. That's not necessary. So we must have something here which modulates this price, which changes this, which modulates this plinth area. That means, for example, suppose you have this. Say suppose still, even if you have a constant here, still it will be doubled. So you have rather this is not what I'm going to teach you. This is the problem is that price depends upon two things: area and plinth area and this number of washrooms. Now, the dependence, of course, it depends upon two things, but the dependence on this and dependence on this must not be equal. Why? Because suppose area is increased, area is doubled. Now price may double or may not double, but price will change. Of course, you will agree with me that price will change. Now the question is, if for the same, suppose now these two have same area, but now it has four washrooms and this is eight washrooms. Do you expect that price will double? If it costs, suppose this house costs rupees 1 crore, it costs 1 crore. Do you think by simply because it has eight bathrooms, its cost will be 2 crore? No. However, if area of this is double of this, then we expect it can be true, but not with the number of washrooms, because number of washrooms are do not have that much of importance as the plinth area. The first important that you will attach with plinth area. So there must be something which will tell us that this is more important, this is less important. A better example, another example from for this is that suppose you go to buy a mobile phone. You go to buy a mobile phone, okay. And while choosing mobile phone, you have to take into account, you have to consider two things about a mobile phone. That is, one is it is say battery life, battery life. This is battery life, for example, and other is something like camera resolution. You want both of these high, battery life high, camera resolution high. But depending upon your choice, what's more important for you, the importance of battery life may be more important than camera resolution for you. So if you have two mobiles, one has a battery life of, say, its battery life is say uh, uh, 24 hours. The other has a battery life of, this mobile has a battery life of 12 hours less. Camera resolution same, then you definitely will choose this because it has battery life more. Now this has more battery life, but that has a better camera resolution. So you will find yourself into in a sort of this what should I say, confusion, what to choose between the two. That then depends upon you, what you like more. If you are more if you give more importance to battery life, then you will choose this. If you give more importance to camera resolution, you will choose this. So the price of a mobile for you depends upon two things. It depends upon battery life plus resolution. Now, but this may carry for you 70% this importance, and this may carry only 30% importance. So relative, this number then shows the importance of this number shows importance of this. How is this 70%? Simply 0.7 is equal to 7 by 10. When we eliminate the decimal, we get 7 by 10, that is equal to 70 by 100, and that is 70%. So you give 70% importance to this, 30% importance to this. These are called these importances of these are called weights. We call them weights. Weights. Okay. Weights. Last example for this is, suppose you have say class 11th examination. In this examination, total marks obtained are 100, total maximum marks are 100, and out of 100, theory is allotted marks of 70, and practicals are allotted marks of 30 practicals. So Importance given to theory is more, importance given to practical is less. So suppose a person obtains 40 mark sorry 20 marks in theory, 20 marks in practicals. Now these will not receive the same importance. We can the score of the student can be calculated by this formula. Total score of a student can be calculated by the marks obtained in theory out of 70. We will write that 0.7x1 plus 0.3x2. I will explain this, and with that we will finish this video. What is this? Score of 0.7x1 and score of 0.3x2. I will tell you what is it. uh, x1 x1 is the marks obtained by different or the marks obtained by different students. One student might have obtained 40 marks, another student might have obtained 30 marks, another student might have obtained say 20 marks in theory. So this x1 will be different for different students. Different students will obtain different marks in theory. These are the marks obtained in theory, and how is score then generated from that? They are given a weightage of, we call weightage of 70%. And similarly, this marks obtained in practicals are given a weightage of 30%. The relative importance of these things. So these questions are very, very important. These questions are very important. And similarly, when this input comes, say x1 comes to this x1 is given a weightage w1 by this neuron. How it is given, you can understand like this. It was x1 that came here, but then this x1 was modulated. Its importance was modulated by a factor, say w1. W1 gives its importance. Similarly, W2 gives importance of this. And what neuron does? Neuron adds these two up. W1 x1 plus W2 x2. A neuron can add signals up. This neuron adds them up. And then what it does? What it does is, here is the neuron. Here is the neuron. This is one input, x1, which is given an importance of w1 x1, w2 x2, w2 x2, and then the neuron sums them up, produces sum of these two inputs, w1 x1 plus w2 x2, and then something very interesting happens. The neuron then, when it receives these two signals, it sums them up. And but these two signals, then it is not necessary that these two signals will able to switch the neuron on. Switching on neuron means that neuron conducts current. The current flows from the neuron. That's not must, because there is a reason. That what is that? A neuron has a certain threshold. It has a certain threshold. Typical value of that threshold is very low. That is minus 50 millivolts. What is threshold? Let me tell you what is threshold. Threshold is that voltage which must be crossed by these two signals together. Only then the neuron will be switched on. If the sum of these two voltages is less than this threshold, then the neuron will not switch on. Something like this, something that you can understand from this. You have a door. Suppose this is door, and this door has here is the door. This was wall actually. This is not door, and this door has a handle here. It takes some force to turn the handle. If you apply a force less than that force which is required to turn the handle, then the door will remain closed. Suppose the force required to turn the handle is, the force that you need required to turn the handle is 4 Newton. 4 Newton force. A small force, of course. Or 14 Newton, because this is too small. 14 Newton force that you will have to exert on this. If you exert a force less than 14 Newton, say 10 Newton, the handle will not, this you cannot turn the knob. If you exert greater than this, say 15 Newton, then the door will open. This 40 Newton is called threshold force. Force is less than threshold or ineffective. Only force is greater than threshold or effective. Same is the case with this neuron model. This is what Macula and Pitts guessed. That was more of a guess than of having some experimental proof for them. Now, what does it mean? It means that if now we have this situation, the last situation, since I don't have enough space there, I will have to come back to this neuron. It receives two inputs. One input is w1 w2 x2, the other input is w1 x1, and then it produces sum. Let me directly show sum. W1 x1 plus w2 x2, this is the sum produced by it. And then see, if this sum w1 x1 plus w2 x2, if this sum is greater than threshold, let us denote threshold by minus b. If this sum of these two is greater than threshold, then the neuron will switch on. If I should have first written this as y. Just 1 minute. If this sum of these two, if sum of these two is greater than the threshold, minus b is the threshold. If it is greater than the threshold, neuron will switch on. When neuron switches on, we say y is equal to plus 1. Plus 1 does not here mean that there is some number plus 1. Plus 1 here means neuron is switched on. On the other hand, if the sum of these two, w1 x1, w2 x2, if this sum is less than minus b, the neuron will remain switched off. In that case, neuron will remain switched off. Let us take this equal to also with that. So this is what we call neural network. Our first encounter with this neural network, the simplest, of course. So what does a neural network do? It takes two or more inputs. This is the simplest, that only two. I'm considering only two in order to keep things simple. Now, what does a neural network do? It takes in two these inputs and then sums them up. Okay, then tests whether the sum is greater than the threshold. If sum is greater than the threshold, then the neuron will turn on. If the sum is less than the threshold, neuron will remain off. It is something like this. When neuron is off, we say output is minus 1. When neuron is on, we say output is plus 1. Again, you see, a neuron has two states. It is digital. That means it has just two states. One is this state, another is this state, an on state and off state. Once again, I stress this point that plus 1 and minus 1 are just labels. They are just labeling what the output should be. Now you can understand the next topic that we have. That will be now quite easy for you. Okay, that's the end of this video lecture. Okay.